Good afternoon. I think the last time I was on this stage was to talk about a cross-country meet in 1993, so it's nice to be back. I'm here today to introduce Jaime Teevan, whom I met at UHS freshman orientation 29 years ago. I did the math, Jamie, that's correct. I checked it twice. In addition to graduating from this impressive institution, Jaime is an alumna of Yale University and received a PhD in computer science from MIT. 2 years ago, after Jaime had worked as a researcher at Microsoft for 9 years, she asked me to be a reference for her when she was applying for a position as technical advisor to the CEO of Microsoft. No one called me, but preparing for that call gave me the opportunity to consider what has made Jaime unique since high school. First, she sees possibilities that other people don't. And second, she persists with the hard work that it will take to make those possibilities a reality. As one example, when Jaime's twin boys were 8, one of them, my godson Kale, asked Jaime if they could walk to his favorite water park. A relevant fact here is that the water park is located 100 miles from their Seattle area home. Safe to say, most parents would dismiss this request out of hand as not possible or too hard. Jaime and Kale walked to the water park, skirting military bases and freeways, and staying in hotels where they hand-washed their clothes. Jaime live tweeted the walk at the water park, and they were greeted when they arrived with a surprise party in their honor, complete with finish line ribbon and DJ. They were minor celebrities at Great Wolf Water Park that weekend. And Kale has a unique memory of time with his mom that, as he puts it, was, quote, very special and also very boring. When I was in high school, I was nervous that the friendships I had made would not endure over time. It's been a pleasant surprise as an adult to find that not only have I remained close to my high school friends, but I've also become close to a number of UHS classmates who I didn't know well in high school. With respect to Jaime in particular, even though she lives in the Seattle area and I live in San Francisco, she is as much family as she is friend. I hope that you also have the opportunity at UHS to make friends who become family. It is now my pleasure and my privilege to introduce my friend and my family, Dr. Jaime Teevan, UHS class of '94, Chief Scientist at Microsoft.
It's a pleasure to be here. And Eleanor and I were walking around the campus a little bit before, when we arrived before this assembly. And it's really surprising to see how much is similar. And I remember being in this auditorium and watching A Streetcar Named Desire, or getting up during all school assemblies to tease my little brother when he started freshman year. The chairs used to move, and so we took them all out when the Gulf War started, the first Gulf War, and sat on the floor and had a big powwow to think about our reactions to that. Eleanor and I, before we came here, went over to Marina Subs, and I had a sandwich that's still there. One California still runs that I used to take to school every day. And it's amazing that so much is the same when you think about how different things are now from 25 years ago. When I went to high school, there was no Twitter and no Facebook. There was no Amazon. If you wanted to buy something, you had to go to a store. And actually, if you didn't know where to buy it, you had to go to the yellow pages and look it up. There were no smartphones, but not only were there no smartphones, there were no feature phones. You couldn't make a call. If you wanted to make a phone call, you had to find a pay phone. And if you didn't have change, you had to call somebody collect. I'm pretty sure my kids don't know what it means to call. Do you guys know? Does anyone know what it means to call collect? Yeah, my kids wouldn't know how to do it. So, I know this all sounds like old person reminiscing, You know, I used to walk in the snow to get to school. But like, honestly, I'm doing it because there's a very important transition that started when I was in high school that we're in the middle of right now, and that we don't actually know what it means or where it's taking us. And it's going to be up to you to steward that change and figure it out. And what I'm talking about is the shift online. So now, I imagine none of you can remember the first time you saw the web, except for all the old people here. So anybody over 30 remembers it, the rest of you don't. I certainly remember it. The first time, I think it was my sophomore year in college. And I was down in this like basement dungeon computer lab in the engineering building. And this guy calls me over and he's like, Jaime, come look at this. And he pulls up a terminal and shows me a web page. And this is before graphical browsers. So the web page is just text. And to get between links, you have to like tab around. It's the links browser. And it was really dumb. You know, I thought Twitter was really dumb too. I'm pretty much not good at seeing things that are going to be interesting in the future. Actually, although that boy who called me over, I fortunately figured out that he was pretty interesting, and we ended up married. You know? So we now have 4 kids. But it was interesting to think about what the web looked like. Why was it dumb? There was just no content. Do you know there were only like 27,000 websites at the time? And only 14% of them were in the .com domain. Actually, most of the content was .gov or .edu. There were fewer than 16 million people on the web. That was less than 0.5% of the world's population. By way of comparison, that's fewer people than live in New York City were using the web at the time. Graphical browsers were sort of just starting to hit the scene. It made a big difference when you could like see pictures and click on things. You know, there was sort of Mosaic came out in 1994. Microsoft licensed it a year later to create as sort of the precursor to the Internet Explorer. Netscape was just about to hit the scene. But what really changed my perspective of the web were web search engines. The ability to search and find the content that is there fundamentally changes the value of the content. And so it's sort of interesting because we're all very familiar with web search engines now. We use them every day. But they were really different. The very first web search engines weren't even search engines like you think about them. So you may be familiar with Yahoo. Yahoo was one of the very early ways people found stuff. And Yahoo, when you entered a query, it didn't actually go do anything algorithmic or interesting to find content for you. It had a bunch of manually created web pages that it would pull up. So you search for dogs, and some human editor has created a web page about dogs, and it will pull up that static web page. And there's a good reason for this. There just wasn't that much information. You know, there were some keyword search engines, but they had maybe 50,000 web pages in their entire index. It's actually conceivable to imagine what it would look like to hand curate all of those things. And I thought web search engines were so cool. They were awesome. So I actually went to go work at an early search engine down in Silicon Valley during one of the first .com bubbles called InfoSeek. And I went on to go do my graduate work on studying personalized search. And search engines, we just knew nothing. We had the business models for search engines weren't developed yet. InfoSeek initially charged people for searches. You all are young enough to not remember the terrible blinking ads that were then used to fund search. We've done a good job now figuring out how to target search to things that are relevant and interesting. But when I think back to that time, I think my enthusiasm for search was correct. I thought it was going to change the world, but I was wrong about why it was changing the world. And what I thought search was going to do, I thought search was like this giant oracle to the world's knowledge, and I could enter any question I had and I could get back an answer. I'm yeah, we can kind of do that. It's pretty cool. But that's not what's changing the way that we interact with the world. The fundamental change is actually in the following number: 15,000 queries a day. And that's the number of queries back in 1994 that web crawler was seeing. And 15,000 queries a day is not very many. In the most recent number I have that's sort of public about the number of queries a search engine seeing is Google in 2017 was seeing 63,000 queries a second. So Google in 2017 was seeing 4 times the number of queries in 1 second that web crawler was seeing a day in '94. But that doesn't matter. What matters is the search engine was seeing how people were using it. And we were about to figure out how to use that behavioral data to improve the services that you're using. And now, behavioral data it's a given, but that's entirely new. Yes, search engines see billions of queries, and web browsers see billions of links, and all of the productivity applications you use see all the words you write. That's entirely new. And we can use that in all sorts of ways. The most simple and the most obvious is we can just understand how people are using products, right? So Yahoo might see, they're building these static web pages. They might see that people are running all of a sudden a bunch of queries for, Starbucks, and then decide to create a static page about that. We can also reflect the data back to people to help them understand what other people are doing or what they've done in the past. Anytime you see a query suggestion when you run a search, that's an example of the behavioral data being reflected back to you. Another thing we see is we can run experiments, do A/B testing. This is just a completely novel notion from 10 years ago, that you can say, oh, I'm going to try one thing, or I'm going to try another thing, and this half of the room is going to use this, and the other half of the room is going to use that, and we'll see which one's better. And you can find weird things. We ran on the Bing search engine, we ran an experiment, the 10 blue links. We ran an experiment trying out different colors of blue. So that when you searched, maybe it's this color blue, and maybe it's a little bit darker, maybe it's a little lighter, and we found the very best color blue. And it turns out what color blue makes a difference in how you click the links. And if we get it just right, more people will click more links, and it results in tens of millions of dollars in increased revenue. And then finally, and probably most important for sort of where we are today, we can use this behavioral data to actually inform the systems that we build. And it's really the availability of large-scale data that has enabled the AI revolution and is enabling us to build intelligent systems that help you get things done. And so after I finished graduate school, I went to Microsoft to go play around with all of the behavioral data. And while I was there, something interesting happened. Web search engines were sort of our first example of a sensor into people's behavior, but that's been increasing now. We're seeing an increasing number of, industrial IoT devices. We're seeing phones. We're seeing smart cars. We're seeing all sorts of ways to understand how people interact with the world and collect it and aggregate it back and learn from it. And at Microsoft, we are building what we call the Intelligent Cloud, Intelligent Edge, which is essentially the infrastructure that we see is necessary to be supporting it. And the important thing about this is it's changing the way that you interact with the world. So, as chief scientist, I often get asked, actually, a lot about, is this a good thing, right? And what does this mean for me? Am I gonna have value? Am I gonna have, what do the jobs of the future look like? I get parents asking, what should my children be learning? It's a big change, it's a big transition, and it's scary. But the good news is artificial intelligence isn't intelligence. It's something that fundamentally relies on our ability to understand the world. The way that AI works, it's essentially a pattern extraction machine, right? You feed in a bunch of behavioral data or a bunch of labeled data, and you learn the patterns from that. And that's awesome. Search engines learn how to do a better job ranking because they can see the patterns in how people search, and they can see us tell them which results are relevant and which aren't, and it can learn those patterns. But it can't learn patterns that we don't teach it. So it's up to us as humans to make the interesting connections. It's up to us as humans to understand the variety of different ways things can happen. You couldn't think about maybe search results are more relevant based on the conversations you're having before you search. That takes people to figure out that that's important and start teaching the system to look for the patterns in that. And once it finds the patterns, then it can do all sorts of stuff. I think, and that's where it augments what we're able to do. Now, one of the interesting things is AI is actually very lazy, and the kinds of patterns that it learns are going to be the simplest patterns. And so it's also up to us to understand whether the patterns it's learning make sense. So here's an example. One way that people use intelligent systems is to screen resumes. And so we'll get a bunch of applications for software engineer, for example, and we might look at the words on the resume and try to decide whether they're going to be a good employee or not. And we'll see, we get this stack of resumes that are going to be good software engineers and learn to identify them for future ones. So most software engineers are men, about 80%. So do you know what the AI system learns as words to look for good software engineers? Looks for he or him or father. And those are not the terms that make sense to be using for identifying somebody who's going to be a good developer. And so actually, it's our job to be thinking critically about the systems that we're building, understand the kinds of patterns that it's identifying, and making them right, not just blindly trusting the system. Another thing that's sort of interesting about AI is it also, because it learns patterns, it's sort of normative. It's like pushing us to the mean. I don't know how many of you use some sort of text completion in your emails now. It makes it a lot easier to write emails from your phone. But the interesting thing is it's also norming the language that we're using and the way we talk to each other. And so actually, like, our value as humans in the future is to not be doing things just like everybody else. It's actually our job to figure out, try a different way to write or a different way to express things. So there's this really interesting opportunity in the future where AI finds patterns, can help us, apply those patterns at scale. There's no way we could look at 1 billion web pages. But doing it in a way that requires us to think on our own and use it to our advantage. And so we're really lucky. I want to say, kind of conclude by saying how lucky you are to be here at this school, where what you're doing is you're learning to be curious. You're learning to be creative, to learn broad things so that you can make the connections you need. I hope you're learning to challenge things and push back, figure out where things, tell people when they're wrong, figure out what's not working, what doesn't make sense, and explore and experiment and do things in new ways. So, thank you.